symmetrical loading, right? So it comes out with Px over A plus by Mz over Izz. Sorry, we do My first, okay? So My, so if the moment is about Y, we take the second moment of area about Y axis multiplied by Z plus by Mz over Izz multiplied by what? Y. It's opposite, yes or no? So the shear and the moment, so if the shear force, what I'm trying to drive is this. If the shear force is in the Y axis, the second moment of area is in the Z axis. Whereas in the moment equation, if your moment is in the Y axis, your second moment is also in the Y axis. So you just need to remember to flip things around. Okay, flip things around. Right. Any questions so far? Are we okay? You are still there, right? I hope so, okay? Are you still there? Yes? Yes. Okay, bear with me, okay? It's not that bad when we go later. It's not that bad, okay? Right. Then we are going to what am I doing? So I'm going to copy. Okay, so we're going to look into this diagram still. Right. So the first expression we're going to write is we're going to find, okay, we're going to find the first moment of area. Okay, we're going to find the first moment of area. About the z-axis. Right, so again, we have in our analysis that this is our Vy. Okay, that's our Vy. So we're going to calculate our Qz is equal to A prime Y bar. Okay, where Y bar or Y, okay, so Y over here is a variable. Okay, Y down there is a variable. So the analysis will be performed from the centroid axis. Okay, so this is rule number 1. Right, so rule number 1, sorry, it's not the datum, sorry, not the datum. Okay, I do apologize. The datum of the analysis okay will be from the centroid axis. Okay, so this is rule number 1. So we know down here that this is a centroid about, okay, centroid in the y-axis. Sorry, this centroid in the y-axis, and this is a centroid in the z-axis. Okay, so we're going to calculate A prime, right? The cross-sectional area. So the straightforward one is the width is B, and this is equal to C minus Y. Okay, C minus Y. So yeah, it is just an equation like this, but we can set rule number 2 now, right? It's equal to what? If you can see over here, it's equal to C minus Y and not equal to Y minus C. It's C minus Y. So the analysis from here, we realize that the analysis, right? Analysis will start at Y max, right? Because C is the distance from the centroid go up to the extreme end. So this is your what? C. So this is rule number 2. So the analysis will start from the outer surface, draw itself back to the what? To the centroid. Okay. Then the next thing, do you see there is Y prime or Y bar? To calculate Y bar is equal to C plus Y multiplied by 0.5. Okay. Any idea why? Y bar is equal to C plus Y bracket multiplied by 0.5. Anyone, please? No? No takers? Right. So we have to prove this. Okay. Do not memorize this. Okay. We keep on memorizing. At the end of the day, when you finish this course, you return all the formulas to me. I don't want that to happen. So what is that? If this point over here, I call this 3. Right. This is my point 3. This is my point 5 over here. Anyone want to guess what is the between, which is your Y bar? Anyone? No? Hello?
4.
Yes, 4. Thank you. So to calculate your Y bar, so this is 3 plus 5 multiplied by 0.5 is equal to what? 4. Just put in some numbers, you can visualize better. Right? So from here, Q, right? Q is equal to A prime Y. So the area is B bracket C minus Y and then C plus Y multiplied by 0.5. Okay. So when you have the expression, you write down that this is equal to 0.5B, right? C squared minus by Y squared. Okay. So now, an important thing to take note. Okay, so I'm going to copy this. An important thing to take note, okay, is that the analysis of for the first moment of area cannot cross over from the centroid. Okay, so this is my rule number 4. What do I mean by that? Okay, if we cannot have a situation, this is not a, you cannot have a situation where you want to find the first moment of area like this, right? It intersects, it crosses the what? It crosses the z-axis. Okay, so this is not possible, right? Right, that is not possible. So you cannot cross the centroid, right? You cannot cross the centroid of interest because you cannot find your first moment of area. Okay, So the only way to do, if you're interested stresses at this point down here, I call this point alpha. If you're interested at the shear stresses of alpha, so what you must do, right? So I'm going to copy. Okay, so this you don't do. Okay, that is absolutely wrong, right? So if you are still interested in alpha, right? If you are interested in alpha, okay. So if we are interested in alpha at this point, right? The correct area to section is here, and this is correct. Why? Because we have to apply to rule number what? We have to apply to rule number, sorry, this is rule number 1, 2, this is rule number 3, sorry. We have to apply that the analysis will start at Y max and it cannot cross the what? It cannot cross the central axis. So Y max over here, so this is going to be your what? Y max, and then alpha point, okay, is your interest in this area, okay, and this area will not intersect your what? Will not intersect your Z axis. Okay, I'm going to carry on Tuesday again. Any questions so far regarding this? Anyone, please? I'm going to stop here. I want you to ask question if you have any, please. Thank you. Anyone?
Hi, Eugene.
Yep.
So we're just splitting up this area because we're going to be interested in analyzing the shear stress at different points along there.
That's correct. Right? Yep. So that's why your Y is a variable. We are going to calculate the distribution. Likewise, we did our distribution calculation based on bending moment. Bending moment, we're also calculating the what? The distribution, right? Because stress is equal to my over I. Your Y is a variable. Likewise, for this, we are looking for the distribution of the shear stress. Okay, good question. Anyone else? No? Okay, if that's the case, I'm gonna stop here, and then next lecture, which is this Thursday, you're gonna have a quiz again. Okay, we're gonna start off. Not start off. We're gonna have the quiz at about the same time, right? Like what we had before. Okay. Anyone else? Any question before I go?
Will the quiz be roughly based on assignment 2?
Yes. It's not going to be exactly the same, but same principle like quiz 1, right? The structure you have to analyze. Okay, there's a big of changes, things like. Now let's talk about the quiz. Do y'all have enough time for the upload? Yes or no? Anyone?
Yeah.
So time is sufficient for all of you.